Okay, so even if the session next door is still going on, I guess we start, and maybe some people will join us later on. Welcome to the Courage to Business Logic. The reason why I've chosen this topic for the talk today is that I work a lot in huge projects on customer side, and when I take a look at the code of the customers, I see a lot of architecture layers, I see generators, I see DSLs used for generating stuff and things like this. But it's very seldom that I can take a look at the code and see the real business logic of the code. And this makes it really hard to, for example, to bug fix the code. If you press on a button and you see that a use case does not really work, you cannot go to the code and follow the use case line of the code. So what I want to do today is just show you some very, very simple tricks or patterns how you can bring back business stuff, business logic into your code so that you can read it, that you can see it, that you can find it, and that you get much more maintainable code at all. But first of all, I will address the problem itself. So why the situation is like this, I explained before. Just imagine you're in a situation like this. You're a young couple, or maybe part of a young couple. You're at a restaurant, and it comes to the moment when one of you have to pay. So normally you ask the waiter, "I want to pay." But what will a typical programmer do at this moment? He will do something like, may I say something like, may I submit my billing info to your merchant account via your payment gateway? And the question is, why do we think in this way and not in a natural language? And why are we so complicated? And by the way, this is a moment when you're the other part of the couple, you should think about a other guy to marry. Okay. Or maybe not, if you're thinking the same way. So the first problem is that we have different stakeholders. We have some in our software landscape. We have something like the technical expert who thinks like I showed before. We have an end user who has a more human language, and we have a domain expert, of course, who has a more business-specific language. And what we really need is a common language for all of these three parties to be able to communicate together. So this quote is taken from domain-driven design, and it says that a common language at the basis for a consistent, or is the basis for a consistent domain model. So when we think about software design, we should think about how to model our world and how to get a consistent domain model. And the first step to get this is to have the same language as the domain expert, as a technical expert, and as the end user. What we can reach then is a rich domain model, or what we should try to reach then is a rich domain model. Not only a domain model, I will show the difference later on, not only a domain model, but a rich domain model. And this means we want to produce software that makes perfectly sense to business, not only to coder. So if you go back to the first slide, this makes sense to the coder, but not to the business guys. And what we also want to do is that we produce software that is always in a correct state, not only partially. And this is a very, very important point. For example, when it comes to frameworks like Java EE. You have something like bean validation, and bean validation helps you to keep your model consistent. But it does this only in special moments. For example, when there comes data from JSF, or when you try to store data in your database. But the whole time between these two moments, you can corrupt your data, or you can corrupt your model and become or get an inconsistent state. And this is something we have to avoid. So before I show these 3 patterns, I want to do a kind of reality check. I call it a déjà vu experiment. And I will show you some kind of code I've seen lots of time at our customer site, and maybe if you think, okay, this is not the way I code, you can leave the room afterwards, but I'm quite sure that you will recognize some of the stuff you have in your code also. So let's start. I talked about a domain model. And what you normally do is you think about your domain, and for example, we have an online shop, you see something like a customer. Of what do? You model a customer like this. And your customer has several attributes, like he has a first name, a last name, date of birth, and last one was address, of course, he lives somewhere. And what you do is you press the right mouse button, and after putting these attributes in, and force your IDE to generate setters and getters for it. But what you do not have at this moment, you have you do not have a rich domain model, but you only have a POJO with no logic, domain-specific logic inside. What do I mean about domain-specific logic? I do not mean business logic like the customer is able to buy something. This is not part of the customer itself. This is part of the use cases. But I mean something like a customer can marry, so he switches his state, his internal state, or a customer can move to another city, or a customer, I want to know his age, for example. And if I want to do this, if I want to know his age, what I normally do is I take the birth date and calculate it all the time inside my code. I will show this later on. So this is not really a rich domain model, but this is only a POJO. And the bad thing about this is you spend time modeling to get a kind of domain model, but you will not get the benefits of it. But you will see this later on. Okay, what can I do to avoid this inconsistent state I talked before? Right now, I have no constructor, so I can create a customer by calling a lot of the different setters. What I normally do is I put some I put some constructors to the customer object, or to the customer class like this. And of course, I have different combinations of valid attributes, so I give a lot of constructors to it, to the customer. And this brings me normally to the constructor hell. So first I start with one constructor, and then I see there's a different or an additional combination of attribute that is valid, so I put another constructor to it, and so on and so on. And this normally leads to problems, which one to choose, especially if I have a no-source view like this in my IDE. I see only that I have a lot of customer constructors with a lot of strings, but I do not know is it the first name, last name, or address, city, street, or something like this. Okay, so, and what about validation? In the view, or on the slide before, of course I could pass attributes with null values. And to avoid this, I can put in some kind of validation to get a consistent, or to create a consistent customer. But we still have a problem with this class like it is right now. Do you see the problem? Yeah, that's exactly the problem. I only guarantee to create it in a correct way, but it's very easy to manipulate it and to set a null value via set first name. So I should place the validation in the setter and not in the constructor. And inside the constructor, only call the setter. When it comes to validation, for example, at this point we have a zip code pattern that we want to validate. So we want to assure that the zip code is correct. And what we often find is that we place the pattern inside the class where we need the validation. For example, this time in the customer. But this also means that we have to place this pattern in all the classes. We need a zip code. And this is, of course, not the right place, because if the zip code pattern changes, we have to change it several times. And of course, you can argue zip code never changed, but in Germany, for example, we had this several years ago. And so this seemed not to be the right place. And conversion, we have the same problem with conversion. We have here a customer controller, which is a kind of use case controller, and we want to alter the birth date of a customer. And we get the birth date via a string and not via a date. So what we normally do is we parse a string and put it to the date. And this time we do it right in the use case controller. And this is something we also see very often in the code of our customers, that this code you see here, this highlighted code, you can find at hundreds of places inside the use case controllers. So if the pattern changes or the formatter changes of the date format, of the string format, for example, you get the dates from another third-party system with another format, you have to change all the places. So this also seems not to be the right place. Evaluation, another point. This time we want to know if the customer is if today is the customer's birthday, and what we have is a lot of code calculating, evaluating if it's the customer's birthday today. Also in a use case controller again. This is something we see also very often. Same problem as before. We have duplicated code all over our code base. So what you normally do is you take this code and put it in a special place. And the special place is called something like util helper manager or something like this. But the problem about this is that you have a special place and your colleague has a special place too. There's no repository of helpers, utils, managers. And because you named this a birthday helper and your colleague named it date util, and the next one named it something else, you will have several of versions like this. So this also seems not to be the right place to put it in. Something totally different, immutability. I talked about validation before and about putting things into setters, validation into setters. But if you take a look at this example, I assured that if you put a date, if you set a birth date, there's a validation that the date is in the future, which normally makes sense. Is in future a new birthday? Yeah. So there's kind of validation, but because the date is mutable, I can get the date via get birth date and then manipulate it, as you see on the bottom of the slide. So this is a kind of hidden setter, which I totally have to avoid if I want to assure that my model is always in the correct state. So I can, via this last line, I can pass a null value if I want. The same with collections. If you work with collections, collections normally are mutable. So if you ask for a collection via a getter, you can manipulate it without using a setter. Last point of the reality check, meaningful APIs. So our goal is to make code readable in the sense of business logic. And if you take a look at the methods over there, it's kind of readable. There's something like find by, it's a DAO. So don't let discuss if DAOs make sense or not, but let's assume they make sense. and I want to find customers via this DAO. And there's something like find by zip code or city, and then you place several strings inside, and then you have something like find by zip code or city with limit, means only the first 100 or something like this, and you have something like find by zip code or city and orders, and you have the same signature string int at this time. Normally, the name of the method will give you a hint what the method does. And if you take a look at the last line again, it's very easy to use it in the wrong way, especially if, for example, if the variables, if the name of the variables are not chosen in the best way, and if maybe you have 100 lines between this stuff. And you always you also run in something we call the refactoring pitfall. So I refactored the first method over there because I also need street as a parameter for the search, and I forgot to rename the method itself. And of course, if you see it like this, you might think nobody is so stupid to do this, but these are all examples from the real world, from the wildlife. So be sure that things like this will happen. So what are the real problem areas? You still are sitting here. This means you recognize one or two of these lines over there. What are the problem areas? So what is the result of the reality check? First of all, what we find very, very often is a kind of anemic domain model. Anemic means you have a poacher with some attribute and some getters and setters, but not any domain model specific logic. And the problem about this, as I mentioned before, is that you spend a lot of time in modeling your domain word, but because of using these poachers with a lot of getters and setters, you can very easily come into an incorrect state. And if you run into an incorrect state, you gain nothing by modeling all this stuff. So you spend a lot of time, but there's no benefit of all. Sorry. We saw non-meaningful APIs, especially what does it mean, non-meaningful APIs? Of course, the name is meaningful, but because we can parse any kind of parameters, because we normally only choose primitives as parameters, it's very easy to misuse these methods. And this is something we want to avoid. What we also find very often, or what I showed on the slide, is missing null value handling. Of course, we had these different kinds of validations, but there were a lot of moments where we could pass a null value directly or indirectly by mutable objects. Inconsequent missing validation, as I said before, bean validation is a nice thing to support you with validation, but it's normally not enough. It shows only that the value that comes in from JSF, for example, or that comes from RESTful calls are valid, and it ensures that when it comes to the database, that the attributes are valid at this time. But it does not assure that the time between the model is still correct. And if you're familiar with the specification, JSF as well as JPA only assures that bean validation works on the first level. So if you have a more complex domain model, for example, you have a customer. Inside the customer, you have an address, and inside the address, you have street and things like this. And you say the customer should be valid with bean validation, and you have a valid annotation at the address. This will not work by specification, or it must not work. There are several implementations that assure that there's a kind of recursion, but the specification says that it must not work. Duplicated code, next point. I showed several slides with duplicated code, and duplicated code is for me also this util, helper, and manager hell I mentioned before. Util, helper, and managers for me are a kind of symbol or a kind of sign that I haven't found the right place to put my code. Okay. All this leads to an absence of code stability. And absence of code stability means that we can run into a real problem when the team grows or we have a team reduction, because this will become a high risk. Because nobody knows what the business logic is about and where they can find the business logic. As I said before, when you click on a button and something explodes on your website, it's very, very hard to find the place where the bug occurred, because you cannot follow the use case inside the code itself. Maybe parts are inside the architecture, parts are generated via DSL, and other parts are in a third-party library or something like this. Yeah, what we often see is something like, what the hell this class is doing exactly. You get code from a colleague, you cannot see the business logic, you cannot read it, so you cannot maintain it, and normally you will not touch it. Even if you're quite sure that several lines of code will never work or will never run through, you will not remove them, because you kind of the word is missing, ängstlich. Anxious, thanks. Okay, and another question: where do this stuff belongs to? Even if the teams get bigger and bigger, or if the teams change over time, there's a kind of pattern that you build your own micro library, something like this, as we said, or as I showed before with this util and helper stuff, because you do not really know if your team has something like a date converter or something like this, or a birth date converter, so you invent your own. And this leads to something we call always a copy and paste design pattern. Okay, so these are all the problems we see in our daily business. And what I now want to do is show you some very, very easy mechanism to get rid of them. And just as a reminder, what was our primary goal? Our primary goal was that we want to create a meaningful domain model with a descriptive API which can be created and kept consistent during its whole lifetime. So meaningful domain model, descriptive API, create consistently, and keep consistently. And this is what we normally call refactoring, what I'm showing right now. And as you know, maybe you know this picture. Okay. WTF means what a terrible failure, as you know. So we want to avoid these terrible failures. Okay. Rich domain model. What does a rich domain model mean? In opposite of this anemic domain model I showed before, we want a domain model which has its business logic inside. And we want validation inside the domain model. We want conversion inside the domain model. We want normalization and consistency checks and all this stuff inside the model. So I do not talk about use case business logic for sure, but I talk about the business logic of the domain model itself. And I want to refactor the stuff I showed before with 3 simple steps. First, I want to introduce something called value objects. Then I want to introduce something called rich entities, and then I will show the builder pattern. So, who's familiar with domain-driven design? Okay, so you should know part of this stuff. Let's start with value objects. What is a value object? A value object is an object that contains attributes but has no conceptual identity. They should be treated as immutable. So, for example, a birth date is a value object, because a birth date is something with a kind of extra logic. A birth date is more than a date, because a birth date normally should not be in the future, but in the past, except you work on a birth station in a hospital, for example. But normally, birth date is in the past. You can ask the birth date how old is a person or is the surrounding object, and you can ask a birth date if it's today or not, for example. So it's more than a date. All this business logic we found in the help on Utils before is normally part of this. But it's not a conceptual identity like a customer, which has a life cycle. So value objects. They have several main topics we see over there, and I will show you some examples of all these topics. So first of all, they are objects, not primitives. They should be immutable, and they do business-relevant conversion, normalization and validation, and are full-blown objects. So if we take a look again at this customer, we found something inside like a date of birth or birth date. And as I said before, normally it should be like something like a date of birth, which is more than just a date, because the date of birth is not it's rule number one. It's not a primitive, but an own object. Of course, a date of birth has a date inside, but it has also some internal business logic, like has birthday today, or like get current age, or something like this. We can assure immutability via this object. So if I call the get date, I can create a copy of it, a new date, and even if somebody manipulates this date, it will not affect our date or date of birth this time. If we need something like parsing a string to create this date, we can put it inside this date of birth object. So the conversion is also part of it. If we need something like normalization, for example, we do not need the milliseconds when I was born or something like this, but we only need the real date, I can also put it inside the date of birth. And this is all stuff I normally find 100 times all over, copied inside my code, as maybe as part of the business, as a part of the use case controllers or something like this. But the better place to put it in is the object itself, because it's logic of the object itself, and not of the surrounding use case controller. Validation could also be part, or should also be part, of this object. In this case, we have illegal argument exception, which is the fail fast pattern. So if somebody parses something that will not work, we can throw an exception. This value object should be a full-blown object, which means that we have something like hash code equals compared to and stuff like this. And if you ask yourself, when should I build a value object instead of using a primitive, it's always makes sense if it's relevant for your domain. So if it's relevant, if it's a date or a birth date, then you should, or if it's relevant that it's a birth date and not only a date for your business logic, then you should build a value object. And just some examples of value objects we use in our project is something like first name, last name, date of birth, zip code, city, country, email, phone number, because we have patterns for this, node, description, year, month, money, of course, because you have currency and a value, big decimal value at this time. And there's a lot of stuff you can use value objects for. So what is the benefit using value objects? The benefit is that the business code is part of the domain and not spread it all over the use cases, the use case controllers, services, utils, helpers, managers, or something like this. So the business code is placed there where it's belonged to. You have none or nearly no non-duplicated code if you use a pattern like this. You have meaningful and especially consistent code. So there's no way, because of immutability, to create inconsistent value objects or to manipulate them that they will get inconsistent. You have readable, readable and maintainable code. If you think about the signature of methods when you parse value objects instead of primitives, you have something like customer constructor with first name, last name. These are classes or types. You have something like city, street number, and stuff like this. So there's no way to use it in the wrong way for methods on constructors. And of course, no more utils, no more helpers, no more managers and friends. And yeah. Again? Okay. The question, I repeat the question. The question was, does the code not get really messy if I have something like customer, get first name, get value or whatever is inside, and maybe you have a chain of 5 layers. This. Before answering this question, I will ask another question. Does this not mean a lot of extra work to create all these value objects? Because before I had only these primitives, and right now I have 4. If you take a look at the slide before, for nearly everything that is relevant for my business logic, I have a new class. So maybe I have hundreds of new extra classes, which I won't have without using value objects. And the thing about this is the extra work, that you have nearly no extra work about this. If you use, we call it a simple value object, a kind of base class where you extend from. So normally something like a first name, last name, or stuff like this is only two lines of code or 3 lines of code using this base classes for this. And if you ask the customer for the first name, of course, you can work with delegates, for example. You can spend a delegate method if it's really important or if it makes sense. And later on, I will come to situation where you, for example, where you need this value in a JSF view. And there's also kind of trick not to go through the whole chain, but to directly access this value. But to answer your question, if you work, for example, with these delegates, the code gets, in my opinion, gets much more clearer and not messy at this time. Okay. So let's come to the next point, rich entities. So what is a rich entity? We have 2 main players. We have the value objects for things like birthday, last name, first name, and stuff like this. So value objects have no no continuity identity. We have the upper side, the so-called rich entities, and rich entity is an object that is not defined by its attributes, but rather by a thread of continuity and its identity. So, for example, a customer is a rich value object. This means if you compare a rich entity with another rich entity, you do not compare the attributes, because maybe my name is Thomas Müller. Of course, it's not Thomas Müller, but let's expect my name is Thomas Müller, and there may be another Thomas Müller, which is a totally different rich entity, but by accident he has the same attributes. So you cannot compare it by the attributes, but by its identity. Value objects you normally compare only by their attributes. So two same birth dates are the same, even if the object is not the same. Okay. So also for these rich entities, we have a kind of golden rules. They are consistent, so we create them in a consistent way and we keep them in a consistent way. Their attributes are value object, not primitives. Just a second. We place setters only if needed by business logic, not because we can generate them very easily with the right mouse button, but only if we really need them. And methods are business relevant operations. This means, for example, if we take a look at this, rule number 1, entities are consistent. We make sure that we can create them only in a consistent way. Like we see over here, we cannot create a customer with a null value for the name. And as we learned before, we should not use a primitive for the name, but we should use something like last name, if it's relevant. If a last name is something different than a normal string. Normal string can start with a number or something like this. And name normally, last name, we normally use name instead of last name and first name in our projects. Name normally has a pattern, has a minimal length, and starts with a letter, for example. Yes. Setter only if needed by business logic, and if we use setter, we also have to assure that we keep the model consistent, as you see here. But normally, it's a good idea to think about the use case you want to fulfill or the business logic you want to fulfill, and to avoid setters, if possible. And I will show an example for this. Here we have something like a customer with the last name, a state if he or she is married, and a person which could be a customer or not. It's not so important in this case. And then if this customer will marry, just will fix something. Let's assume it's a person. So if this customer will marry another person, what you can do is you can call 3 setters just to make sure that everything works. But if you forgot one of the setters, what happens? You get into an inconsistent state. So this is not really business logic. So what I would do at this moment is just delete the 3 setters if they make no sense, or if it makes no sense to use them alone, and have a method like this, marry. I marry another person and get a new last name, for example. And inside this method, I can, for example, do something additional, because I can guarantee bidirectional consistency. Because normally, if I marry a person, it's very common that the person marries me too. And this is something I should assure inside my code. And if you take a look at this, you will not do this normally you will not do this with a normally setter, or if you have a setter, it will be if you assure bidirectional consistency inside a setter, it's a non-expected side effect of a setter. If you see a setter in your code, you normally do not expect that there's something additional going on than just set the attribute. So it's a good idea to have something like methods like this. Okay. What we have done right now is we have introduced value objects, and we've introduced rich entities. And normally you have a rich entity which with several of these value objects inside. And of course you can also have rich entities with entities inside, and then you call them aggregates. And now kind of a quiz. If you have something like an address, I showed addresses before. An address, is this a rich entity or value object? It depends. Why?
Because there are some guys doing some very advanced address stuff where you can actually find an address in the database having a unique key. Whereas for some other people it's just it's something where the guy lives, I don't care.
That's exactly the answer. It depends. Of course, something like a birth date, even a birth date, as I said before, if you work in a hospital and it's you work on a birth station, the birth date can vary through the lifetime because if you're pregnant, you go to a doctor and the doctor first announces the birth date for the 1st of November, and 1 month later he said, no, it's not the 1st of November, it's something like end of October or something like this. Then it will become a rich entity, but normally it will be a value object. And as you said correctly, the same is for addresses. Addresses normally, in most cases, are value objects, but they can also be rich entities. So you always have to ask yourself, is it something that can vary through the life cycle, through its life cycle, or if it's is it always the same? Okay. Last but not least, I will just introduce a builder pattern. I'm quite sure everybody of you knows the builder pattern. Who does not know the builder pattern? Of course, it's stupid to ask this question right now because I said everybody of you knows this. But let's assume everybody knows the builder pattern, more or less. And as I said before, what we want is to create a rich domain model, which we can reach with these value objects and rich entities. And that I said also that we want to create and keep it in a consistently way. So, builder pattern in a nutshell is a pattern to create objects in a consistent way. And this is the answer to the constructor hell anti-pattern I showed on one of the first slides. So if you have different combinations or permutations of attributes which will end in a consistent object, it's always a good idea to use a builder pattern for it. The idea of this builder pattern is to have a step-by-step approach. This means you fill the builder pattern or the attributes of the builder, and in the end, you call a method, for example, build, and this will result in a valid and consistent object. And we have a very easy example over here for a builder pattern. Class address, and we have a constructor. And inside this constructor, we check every attribute if it's set correctly or not. This is kind of poor man's builder pattern. But it's not really nice. Something nicer is this. You have a builder first line, first code line, new address builder, and then you set different values for this address builder, and then you call something like builder.build, and you get something like a valid address as the result. And this also works for frameworks like JSF. So you bind, in this case, you would bind the builder to the front end and not the object itself. You have to manipulate the lifecycle a little bit, but these are only some lines of code. Okay. So let's take a look inside the builder. The builder looks like something like address builder with all these attributes, and if you can set the values. So the builder has setters, but the object itself, the address, will not have any setters to manipulate the values. We only have business logic methods inside this address. For example, moves or something like this. And of course, this is kind of nicer than the stuff we saw before. But if we take a look at the code again, and I said one of our goals is to have readable code and maintainable code. This is not so clear what the code is doing if you take a look at this. So it would be nicer to have code like this. So if we want a new address, we call on the address a static method called new address, and then we say this is a new address for street number, off street, in city, with zip code, lying in state, off country, and then call build. This is something readable. And just think about that the parameters of the Fluent API methods are value objects. So you have something like for street number and the parameter street number, off street and the parameter street, in city and the parameters of type city. So you cannot misuse this. You cannot make any mistake. And how does it look like? This builder, it's not complete, so you cannot copy it, and it will work. But you can take a look at our blog, www.openknowledge.de, and you will find several examples how to build a builder like this, and you will also find examples how this will work together with Java EE frameworks like JSF. Because the big problem about, the problem about a syntax like this is that several framework needs setters. So they, like JSF, like other frameworks. And this is also the reason why a lot of people use this endemic domain model, because we need the setters for our frameworks. And what you do in JSF, for example, or what you can do in JSF, for example, is you can manipulate the lifecycle or write a different EL resolver so that that instead of setters, this EL resolver will also work with for, off, and stuff like this. So what we do, or what we do in projects often, we just look for the attribute name like street, country, and stuff like this, and look for special prefixes. And if there's a method with a prefix, it's for us it's the same as a setter, and so we can use this in JSF in a normal way. So just this means that we can bind the builder to the JSF views. So the conclusion of what I have shown is that the design is a code and the code is the design. So it's not about having several layers of architecture and generators and stuff like this if it comes to business logic, but to have domain-driven design so that you can see the business logic inside the code itself. And you ask if this does it mean we have more method calls to do, for example, or more code to write? And another question we always hear is, do I have to change my code if the business logic change? Normally, and that's exactly our answer. Why the hell not? Because the code is the business logic. And if the business logic of your domain changes, and you do not have to change your code, then there should be something wrong with your code. And just think about it. It's very important. Okay. This was my little talk about the courage to business logic. And as I said before, my motivation for this talk was just to bring the logic back to the code. And especially in huge projects, we see very, very often that you cannot find the business logic at all inside the code. And it's very easy to, with this simple patterns and some different architectural patterns I haven't shown today, it's very, very easy to build a much more readable code and readable, meaningful and maintainable code. And the positive thing about this is that if developers talk about the code, they talk about the domain. They do not talk about how to build a cool generator or something like this. And normally, you or your company earns money with the domain or with business logic and not with architecture and stuff like this. Okay. Any questions?
I have to say I feel really ambivalent right now because I am normally very much a fan of anemic model, actually rather dry age model, you know, like completely logic free. But I think you make an excellent case for the opposite approach. But what somewhat confuses me is if I'm wondering if there's not a very easy way to fall into validation overconfidence. For example, you mentioned the length of a name as a possible validation target. And like, for example, in German or surrounding languages, I couldn't really think of a name that's shorter than 3 letters. Or actually Unicode code points, and there comes the next problem. But for example, then with German reunification, quite a few Vietnamese people became German in the whole new country, and then you have names like NG. And of course, you have to account for that.
Yep.
So, different example there is about validating names. There is a long essay by Patrick McKenzie about what you shouldn't assume about names. And pretty much all of those assumptions will probably end up in the model there. The same thing about marriage. For example, the definition of marriage, which used to be the classical example of a pretty constant relationship that needs validation. Well, the definition of marriage has been changing very lately. So I wonder how hard it would be to account for variations in the logic through time or physical or legal space, and how to account for that in a very rich domain model.
Okay. Shall I repeat the question, or was anybody
It was really long.
able to understand?
Repeat it.
Okay. Short version. This guy is a really fan of the anemic domain model, or maybe even poorer version of it. Sorry for the poor, with nothing inside. And he said, I showed the upper side, and he's a little bit of, and as I understood, you liked it, but you said you see a risk for over-validation, for example, or for things that can change over time, or that can be different in different countries or stuff like this. For example, address validation is a very good example. And your question is, how can we manage this inside a rich domain model? First of all, over validation. What we do is we validate only things that are relevant for our business logic. So if we have a German online shop, for example, we validate for German addresses, and not. It makes no sense to have a worldwide address validation module or something like this if the business case is German law at this time, or marriage, for example, how to marriage. So, and we do not validate, and we only validate things that are business relevant. So if it's not relevant, that the name is valid, then for us if it's not business relevant, then it's only a string. If we think it's relevant for any reasons, because there's a use case that assumes a certain length or something like this, we implement it. And the only trick is that we implement it in one place instead of spread it all over the code. So if it's business relevant, you also have to implement it. Even if you use a dynamic domain model, you need a service, you need a helper, you need a util, you put it in a use case controller or something like this. But if it's relevant, you have to do it. If not, you end up in an inconsistent model, or you end up in a non-valid situation. If there's something like in German law, it's different than in English law or something like this, we use variant points. This is also part of domain-driven design. What I showed is only the topic of an iceberg, of course. And Eric Evans says, if there's something like this you talked about, you have to make it explicit. And what you can do is you can inject the algorithm. Then maybe it's not inside the value object or inside the inside the rich entity, but you inject the special version of checker or something like this of validation. That's what we do. And just from my experience, if you make it explicit, it's not hidden, it's not generated, it's not Voodoo or something like this, but you make it visible for everybody, that you inject something and maybe you have a special qualifier what you inject or something like this. It's very readable and it's very maintainable at this moment. And the good thing, as I said before, what we learned of this is that especially young developers start to talk about business logic instead of technology. Maybe the old developers also, of course, but they did it before because they learned over time that it's important to care about business logic. But especially young developers tend to spend a lot of time with architecture stuff or technical stuff and what they learned at university. And nobody learned in university how to analyze a use case, for example. Does this answer your question?
You showed like that you put business logic when you say this is today the birthday of the person. But usually a business is not driven by this. The business is if it's the birthday, I will give him a discount of 10% and he will be very happy. So I have one object and maybe it's very hard to get the other object like the product or the card. And what do you do in the middle? Like, do you pass your objects into each other and you don't have a service layer? Or where does this high-level business happen?
Yeah. Good question. The question was, I showed very simple examples where the business logic was part of the domain model, or the small part of the domain model itself. For example, the customer married some other customers. So you can only marry other customers. You cannot marry another person. Or a birth date. I can ask a birth date if it's today or not. And you ask, but what's with business logic that is concerning more than one object, for example, or which is more valuable or stuff like this. And this is also defined in domain-driven design. What you do at this moment is that you really use this, they call it service. It's a little bit different than a typical service layer, but they call it service. And every time you have logic concerning more than one value object or more than one rich entity, you path them to a service, and the service will do the business logic for you. So this is what you normally put in the use case controller. And how can you decide if it's if you should build a service for it or if it can be done by other mechanism. And the rule of thumb is that every time you can decide it by the object itself or handle it by the object itself without any additional information or without passing any additional values to it, then it should be inside the value object or inside the rich entities. And every time you cannot do this, you should have a service for it. So, of course, we have layers. Normally we have a multi-layer system, but inside this multi-layer system, we use these objects.
Do value objects and rich entities have some issues on performance? Because you are creating a large number of objects, are you experiencing any performance?
Okay. The question is, do value objects or rich entities have any influence of the performance of the system? And the answer is, it's only from my point of view, no. Because, for example, we work a lot of, or these value objects are immutable objects. You can use final, for example. Garbage collection works very well with these objects. And objects creation is not so expensive anymore as several years ago. And if I take a look at the systems we built with these patterns, as I said before, we still have a multi-layer architecture, we still have services and stuff like this, but we place the logic that belongs to an object inside the object. And from my point of view, the performance issues never laid inside these objects, but in database access or something like this, or marshalling, unmarshalling for RESTful services using XML instead of JSON or something like this. So my answer to this question is no. Maybe if you have to produce millions of objects, you better run with primitives. So it's not the best solution for batch jobs, for example. Okay. Yeah. The question was how do we avoid to double all the validation code? Because I said, of course, we use bean validation, and bean validation for us is a nice helper, but it's not enough because it only works in 2 moments right now, when data comes in and when data goes to the database, but not in between. And as I said, we have a lot of this validation code. And yes, we double this validation code. What we do is, for example, if we have pattern checking or something like this, we use constants for these patterns and reuse this constants. So we use this inside bean validation and inside the setters and getters. But when it comes to validation, as I said before, it's not only about setters, but as we have seen with this marriage example, the validation is that you cannot marry 2 persons at the same time. This is in Germany. And I guess it's the same in Austria, I'm not quite sure. And this is an other kind of validation than the length of a name or something like this. Okay, maybe one last question. Okay, the question was, these value objects are these JPA, you mean JPA entities or something different? This is one thing I haven't shown today, how to use this stuff with other frameworks like JSF. I mentioned JSF several times, and JPA is the other side. And the good thing about a value object is that it's embeddable. So you just have to write it as an embeddable, and the rich entity is an entity. And this works quite well if it comes to queries, for example, to name queries or some other queries. You can just normally this value object like the birth date, there's a date inside, and you can use it in a simple query without any problem because it's an embeddable. So it works very well with JPA and also with some tricks also with JSF. There's a nice example if you are interested in domain-driven design patterns in Java and how it runs together with Java EE. There's a cargo tracker example. Just browse or Google for cargo tracker and DDD, and you will see it's a kind of blueprint. There's a Java EE blueprint, and this is a kind of special Java EE blueprint for domain-driven design, how this works together. In my opinion, it's a good starting point how you can organize your project, because there are a lot of more patterns in domain-driven design than I showed here. These are only the very, very simple stuff where you can make your code much more readable with very little effort. But this cargo tracker example is a good starting point. In my opinion, they could have done a little bit more when it comes to value objects. They use a lot of primitives, for example, but at least it's a very good starting point. Okay, thanks a lot for your time. If you have any more questions, I'm willing to answer them outside while having a beer, as far as I understood. And yeah, thanks a lot.